Okay, finding y prime here is equal to derivative of the numerator times the denominator. I'm going to write it out before I do it. Minus derivative of the denominator. Derivative of x squared is 2x times numerator. Just because numerators was a bit more, I would say needs thinking, I wrote it as a separate thing. So derivative of the numerator times denominator plus derivative or minus derivative of the denominator times numerator divided by denominator square. So now I only need to find the derivative of this one. Derivative of e to any power, e to power u, is e to power u, but then multiply by whatever is derivative of the inside function. Multiply by derivative of u if there is anything inside that function. So in this case, I'm going to write it with red. So e to power 1 over x, that's this piece, e to u, times derivative of inside, derivative of 1 over x. Derivative of 1 over x is equal to, you can rewrite this one as x to power negative 1. So derivative of that would be bringing negative 1 to the back, so it's negative x, and then subtract 1 from here, it's negative 2. So rewriting it as negative 1 over x squared. So derivative of e to power 1x is e to power 1x times negative 1 over x squared. So I'm going to write that down. So it's negative 1 over x squared, e to power 1 over x times x squared minus 2x e to power 1 over x divided by x to power 4. Okay. In order to move forward, this is not going to be our final answer. We need to simplify when we have a fraction and a fraction. We call it complex fraction. We need to simplify things around. In this case, we were lucky enough that x squared and x squared cancels. But if that's not the case, then we need to simplify the entire fraction. Okay, so it's equal to negative 1 e to power 1 over x minus 2x e to power 1 over x to power 4. Remember that someone might want to factor e to power 1 over x. I'm fine if you leave the answer this way right here, as this to be your final answer. Okay. Next question. So this one is tan. You may memorize derivative of tan or just memorize derivative of sine and cosine. I always write tan as sine of t over 1 plus t squared over cosine of t over 1 plus t squared, and find the derivative of that. So let's take care of each piece and the entire fraction. So this is a fraction, so you would say derivative of the numerator times the denominator minus derivative of the denominator times numerator. So let's do that. So derivative of the numerator, I'm going to first write it and then do it. So derivative of the numerator times the denominator minus derivative of the denominator times numerator divided by denominator square. Okay. So let's work it out. Derivative of the numerator, derivative of sine, is cosine. Cosine of t over 1 plus t squared. So that's the outside function of sine. Now multiply by derivative of inside times derivative of inside, derivative of t over 1 plus t squared. That itself, I know math needs patience. So that's derivative of the numerator times denominator minus derivative of the denominator times numerator divided by denominator square. So that's 1 plus t squared minus 2t squared over 1 plus t squared to power 2. Simplifying here, it's negative t squared plus 1, or 1 minus t squared, over 1 plus t squared to power 2. Okay. So here is what we're going to write here as a derivative of inside. So that would be 1 minus t squared over 1 plus t squared to power 2. Okay. Times cosine times this one, cosine of t over 1 plus t. If you look at this one, we are multiplying this by that, so it's the same thing as this one. It's enough that we add just the power here because it's the same thing, so I'm not going to rewrite it to take up space. Minus, now going to this piece, derivative of cosine of, imagine the box. Cosine of the box, derivative of cosine is negative sine, so this turns to be plus sine of t over 1 plus t squared times derivative of inside. We already found the derivative of inside using here as of our side note that we had. So I'm going to write that here. 1 minus t squared over 1 plus t squared. Please do not make any magical cancellation here like t squared with t squared, so nothing cancels. Okay. And then multiply by this sign. But this sign is a copy of this one, so if I'm multiplying that right here is the same thing as if I add a power of 2 right there. So that's going to be to power 2. I'm going to erase the derivative piece here. Divided by cosine square of t over 1 plus t squared. Okay, now I'm going to factor out this one and this one. So I'm going to combine them by factoring these two out. So if I factor that out, let me use green for this line, 1 minus t squared over 1 plus t squared to power 2 times cosine square of this quantity that I have here plus sine square of the same quantity that I have here all over cosine square of t over 1 plus t squared. So beautifully, cosine square plus sine square of the same inside would be equal to 1. So the final outcome for this question is equal to that 1 over cosine square, which I can write it either 1 over cosine square or secant square of t. Let me just write it on the next line so I have more room. So that's equal to secant square of t over 1 plus t square. So that's for this piece together. 1 over cosine square is secant square times 1 minus t square over 1 plus t square square. Okay, and that's the final answer here.